Challenges faced and lesson learned during design and construction of Marina Square project and use of computer-based novel technology for structural monitoring. That is the theme of today's session. This session will be conducted by Engineer Dhammika Silva, General Manager and Head of Engineering Designs, Access Engineering PLC. To welcome this distinguished guest, including Professor Nana Akkara and other fraternity members, I think I'm not the most appropriate person. I would say in this premises, the most suitable person to welcome all of you from who is representing the fraternity, it is Engineer Nandan Amunuthuduwa. Engineer Nandan Amunuthuduwa is our Director, Industrial Sales, Building Materials and INSEE Concrete. Engineer Nandana, over to you.
Thank you, Dishan. It is a great privilege and honor for me to welcome you from the fraternity, including Professor Nana Akkar and other eminent professionals from the construction industry. And further, I would like to welcome all the participants who are participating to this session via Zoom. And special welcome to the members who are joining from our INSEE family from other countries like Thailand, Vietnam, and Cambodia. This will add value to this session. Actually, this is the first session for the year, and we have a lineup of another sessions which are planned to do in the coming months as well. And we hope the participation for those sessions from you and take the maximum out of it. So I extend a warm welcome to our resource person today, Dhammika Silva. Actually, he's a expert in engineering designs, and he has wealth of experience in designing of multi-disciplinary projects in the country. So when it comes to high-rise buildings, water retaining structures, especially bridges and flyovers, plus highway designs for few highway projects. So he has wealth of experience under his belt. So I humbly request you to take the maximum out of him, and we are offering a Q&A session as well. So I think you can tap to his knowledge and get the maximum benefit out of this session. On the other hand, I would again like to welcome you, and we hope that our intention of and our motivation of this premises and INSEE i2i collaboration space, we are running this facility to improve the knowledge of the industry experience and the technical collaboration, because we have wealth of experience within our group, and we can offer various technical solutions to the construction industry and the problems which are facing and in the industry, and we can facilitate testing and modeling of the thermal behaviors and other things, and we openly invite you to utilize this facility, because we are here running this facility for this construction industry. So take the maximum out of it, and thank you again. Welcome.
Thank you. Thank you, Engineer Nandan Amunuthuduwa. Engineer Nandan Amunuthuduwa is our Director for Industrial Sales, Building Materials and INSEE Concrete. Before I invite Engineer Dhammika Silva, I'm honored and I'm uh, uh, privileged to present his profile to you all. So today the topic is challenges faced and lesson learned during design and construction of Marina Square project and use of computer-based novel technology for structural monitoring. The session will be conducted by Engineer Dhammika Silva, General Manager and Head of Engineering Designs, Access Engineering PLC. He holds both Bachelor of Science honors and Master of Engineering in Structural Engineering from the University of Moratuwa. Engineer Dhammika is a fellow member of the Institute of Engineers and a member of the Society of Structural Engineers of Sri Lanka. He is also recognized as an international professional engineer. With over 20 years of experience, Engineer Dhammika specializes in design and construction consultation for large-scale buildings, bridges, and various other types of structures. Among the lengthy list of projects carried out by Engineer Dhammika as a design team leader, I would like to mention few of them. Marina Square Apartment and Commercial Complex, design, construction and financing of balance work of the housing project at Elliott Place, design and construction of multi-storied public car park at Union Place, design, construction and financing of affordable houses in Orugodavatta Colombo project, middle income families, and the Stadium Gama project, housing development project at Blue housing project for the government employees at Baralla, Access Tower 2, design and construction of 600 apartment units at Henemulla, when it not only the high-rise buildings, but also the projects, bridges and flyovers, design and construction of Central Expressway, Section 3, design and construction of Gatambay flyover in Kandy, Pohuvala flyover, Slave Island Bridge in Colombo, Keel City Waterfront Development Project, design and construction of flyover in Rajagiri. The list is lengthy. I think this information is more than enough to understand who is Engineer Dhammika Silva. Engineer Dhammika Silva, may I invite you to address the gathering and to present your presentation. While I invite Engineer Dhammika Silva, let me invite all the members of the audience. You can use the Q&A box, Q&A space in the webinar session to mention your questions, queries, and ask your questions. Engineer Dhammika Silva.
Good evening, everybody. Thank you very much for kind introduction. First of all, I would like to thank INSEE Corporation, INSEE Cement Limited, especially Nandan Amantudu and Dr. Musa, giving me the opportunity to present, to share my knowledge in this forum. Today, my topic is challenges faced and lesson learned during design and construction of Marina Square project and use of computer-based novel technology for structural monitoring. I am Dhammika Silva, General Manager, Head of Engineering Designs, Access Engineering PLC. Session outline, first introduction, coming into the project, challenges faced session. First item, rock profile and basement excavation. Second, structural form of the tower. Third, temperature control of the transfer beam and construction methodology. Fourth, BIM integration. Fifth, novel computer-based structural monitoring system. And finally, conclusion. I'd like to get introduction like this way. The main focus of sustainable business is to understand the client need and expectation and fulfill them to the maximum extent possible. Engineers can play pivotal role by introducing efficient and effective system and value engineering. You have fulfilled the client's need and expectation in this kind of recession period. Now, you know that in the construction industry facing difficulties in these days. So in this recession period also, your sustainability is not big challenges to you. Next, most of the important decision made by the responsible engineers of the project will affect the time, cost, and constructability of it. Sufficient and accurate data, along with the rational evaluation, will help to arrive at the most suitable and constructible and cost-effective solution for the project. If you come across issues at the site, so issues at the project, what you need to get is you need to have some set of data, and you need to rationally evaluate those data, and you need to, by using those data, you need to evaluate it, and you need to get the decision rationally to minimize the cost as well as to the constructible way, and to minimize the environmental effect of it. That is the concept we need to practice. So with that note, I would like to go to the my project, Marina Square. I will give you some overview of the Marina Square project. Project description is, this is largest single phase condominium development in Sri Lanka. Joint venture between Access Engineering PLC and China Harbour Engineering Corporation. Access, the share amount of 66.67% and China Harbour 33.33%. 1088 luxury apartment units, total with 1 bedroom, 2 bedroom, 4 bedroom luxury apartment options. 150,000 square feet commercial spaces, including recreational areas, offices, shops, etc. This is 35-story, 5 building blocks in 4-acre land. You can see the site layout. It's just adjacent to the Ceylon Tobacco Corporation, nearby the port. This is the close-up of the land. It's like L block land. You can see 4-acre land. This is the architectural 3D view of the project. Some close-up and architectural the views of the project. In order to get some understanding of the magnitude of the project and what's the extent of the project. This is another close-up and few angles. This is actually the ongoing construction, the picture in year 2022. And this is 2 months back. In compared to the architectural view, this is the structure has been completed at the stage. You can see the architectural view, the 3D view, almost equal to the existing structure. You can see right-hand side the port elevated road, and also here the port few 100 meters nearby. So I will move into the challenges phase. So when we are considering the challenges of the project, we can divide challenges into 2 parts. One is challenges that has been faced previously, and other one is the challenges new to the project under consideration. In this project, we have faced a lot of challenges, but I have listed out few of them to give you some understanding of those challenges. First one is the shallow and varying rock depth, because this is 4-acre land. Initially, we observed that the rock depth is very shallow in some area, very deep in some other areas. So initially, we plot the top of land like this way. You can see the front road level is, if considered 0, the internal the ground levels are around 1 meter below the front road line. The length of the site is around 189 meter. Width of the site is 175 meter, as you can see. This land initially belongs to some other client. They had their own proposal for the land. They had done some set of boreholes. Initially, we used those boreholes for our designs because these boreholes, if we see the detail of the borehole, you can see some different in the rock level. In the borehole 1, you can see the 9 meter, borehole 2, 6.5 meter, and 9.7 meter. It increased up to the 17.2 meter. Again, it's going down to the 15.7 meter as well. So with that detail, we wanted to get some more detail of the rock data, actual rock profile of the site. Because if we did the designs without considering all this information, we would have ended up with a mess at the end of the design, because we wanted to maximize the parking and the basement depth. If we with the design without considering all this information, we would have ended up with the mess. So therefore, we recorded all data like this way, and we obtain all the rock profile data within 15 meter grid in this site. Whole site we explore 15 by 15 meter grid. More than 100 boreholes we performed in this site. This is in order to get the rock file of the site, because this is very vital information. Otherwise, if we plan the depth of our basement more than this rock depth, finally it will end up with the project issues. So therefore, based on those data, we plot all the rock profile, the contours, the same 0 we consider here. You can see in front it's around 10 meter, here 7, again 6, and very nearby it's 16 meter. So within 15 meter difference, we can see 10 meter difference in the rock. And here also it's 18 and 7 meter. Within around just more than 15 meter, we have more than 10 meter rock depth difference. So we plotted all this information in the section as well. In the 15 meter difference, we observed that approximately 12 meter difference. The dip angle is 45 degrees, like that kind of information we obtain. So therefore, initially we had the idea to go for deep basement, but if we consider the 8 meter basement with the pile cap depth, the rock excavation would have been done like this red color patch. So finally, the another proposal was there, the 8.5 meter depth, the basement depth. If we got that decision, then rock excavation would have been done like this way. So if we got this kind of decision, this would lead to the very difficult situation when we are going to the construction. Without having this information, if we arbitrarily got this decision, then we would have ended up with the mess, because in this area, the Ceylon Tobacco companies there, in this the set mill and all other important office, and the backside there were a lot of the community areas and all these things. So therefore, if we plan to do the rock excavation, then the time, cost, and also the environmental issues and all these things will come into the picture. So therefore, what are the lesson learned here, and what are the decision what we have taken? So here information gathered are minimum rock depth of the vicinity is 6 meter, maximum rock depth is from the EGL 18 meter. Basement clear height requirement is 4 meter. This is minimum requirement. So therefore, challenges faced in this because of this situation, the issues related to the design, because we can't put our basement as our requirement. We need to consider this aspect also in our designs. And rock excavation involvement. And the next is issues related to the constructability, vibration, cost, and social issues. So what are the decisions taken? We suggested sub-basement. In this sub-basement, 2.5 meter excavation from the EGL. So previously I said that the land is around 1 meter below the front road line. So because of this sub-basement, our ground level came up to the 1.5 meter above the front road line. So 1.5 meter the existing ground level, but 0.5 meter above the front road line. So therefore, this decision was very important, because when we are considering all the sewer and the stormwater and all these things, also we could manage with this decision. So also, and the other thing is the file foundation done for all over the site. Without doing, if we didn't consider this kind of decision in some area, because rock level is very high, then in some area we would have to go for the pile cap directly on the rock. In the other area, we need to go for the pile foundation. So therefore, the foundation system is different. In that case, the different behavior of the foundation system, that is also a structural issue, will come into the project. So therefore, with this information and with the challenges faced, and this is the decision taken in this issue. So this is the first. So we'll go to the second challenge phase. In the initial stage, there were two types of architectural design for this building. One is the shear wall structure. Other one is the wall frame structure. I will briefly introduce what are the type of structural form for the high-rise building. This is what we call rigid frame structure. The column and beam connection with the moment resisting joint in the main structural form is this system. Lateral stiffness by rigid frame action. Generally, when we are talking about the high-rise building, we are mainly consider about the lateral loads. There is a reason for that, because the high-rise and medium-rise building we can consider as the vertical cantilevers. So the lateral loads are the most important load which we need to consider in this structural form. So therefore, that's why the peoples are mostly talking about the lateral stability and lateral forces about the high-rise building. So the vertical load, anyway, we are designing the element for the sizing. We are doing the element to take care of the vertical load, but for the lateral load, the structure is very vulnerable. So therefore, mainly people are talking about the lateral load when we are considering the high-rise and the medium-rise building. So this is the rigid frame structure, lateral stiffness by rigid frame action. The second one is infill frame structure. The column and beam connecting with the moment resisting joint like this way, and lateral stiffness by infill act as diagonal strut and frame action. With this condition, as well as diagonal strut action also in the infill, the infill masonry or whatever the concrete kind of thing can be there. So this is economical up to 25 stories. This we can go up to the 30 stories. As introduction about myself, you observe that we have done the Stadium Gamma project. We have considered this rigid frame structure in that project. All of the UDA project what we have done up to now, we have considered the rigid frame structure. but we have done the infill with the masonry. We didn't consider the infill, the additional capacity that we can taken by this infill diagonal strut action. So therefore, those structures has additional lateral carrying capacity. So we didn't consider it's like a redundant. So next, I'll go for the shear wall structure. This is the shear wall, internal shear core, and the outer and the inner shear walls. Shear core and the outer shear walls are there in this structure. Vertical and lateral load resisting by using the shear walls. Economical up to 30 to 40, 35 to 40 stories. This is wall frame structure. The internal shear walls and the rigid frames are there. The shear core and rigid frame structure. Lateral stiffness by the combined shear core and rigid frame action. This is economical up to 30 to 35 to 40 stories. This is 40 to 60 stories. So these are some other structural form, the frame tube structure. And you can see this frame tube structure, you can go up to the 60 stories, and steel frame tube structure 80 stories, and tube pin tube structure also you can go for 80 stories. So now I would like to go to the challenges faced and what are the decisions that we have taken in this case. The structural form. We have two structural form given by the architect. One is shear wall structure, and other one is the wall frame structure. Two structural form given by the architect. So we selected some criteria to evaluate these two systems. What are the criteria? These are the criteria: the structural performance, financial performance, and the functional performance. These are the criteria that we have considered to evaluate these two systems. So these are the two the structural form that they have given to us. The first one is the shear wall. The second one is the wall frame structure. So we prepared the quick model, initial model, to these two type of structures: shear wall model and wall frame structure model. And we have considered some set of parameters in this evaluation. For the structural performance, we have considered the building deformation in x direction and y direction, and drift index in x direction and y direction, natural period of vibration. This is most important, along wind and crosswind acceleration. Also, we have considered seismic consideration also. In this, the shear wall option, all these things satisfied, but wall frame option, the crosswind acceleration came to the very marginal point. So we had the opportunity to improve this wall frame option, also with some modification to the column and the center core. And we also consider this is the wall frame option also we can consider as the one structural form in this. So therefore, we evaluate the other aspect as well, functional performance. What are the parameters checked? Apartment laying out flexibility. These are the parameters checked: structural elements visibility and outside view from the inside of the apartment. The apartment laying out flexibility, if we consider the wall frame option, you can see that I'll go to the this wall frame option. We have big column here. So in that the set of beams also running here and there. So therefore, the apartment laying flexibility is not so good in that option. So therefore, in this compromise some extent due to large column. Here, flexible laying out option is there. Structural element visibility, visible some column and beam are there. No visible column beam visibility. And outside view from the inside the apartment, because this shear wall option, our outside walls are also load bearing, the lateral load bearing the wall system. So therefore, we can't open those walls as our requirement, because that is the we need to get some the precaution when we are giving the openings to the door and windows. So, but in this case, it's not that issue. So we can maximize since there is no structural scheme. So then financial performance. We evaluated the concrete amount that we need to use in these two options. This the calculation actually it's not applicable to today's context. This is actually a 2018, 2017 and 2018 we did this comparison. This is for two front towers. The structural, the cost saving for the wall frame option is was 158 million. So therefore, we summarize all these information like this way. The criteria consider structural performance, financial, functional performance, financial, commercial performance. Shear wall option, the structural performance is good, the wall frame option is average. Functional performance good, the shear wall option, but wall frame option is its average. So financial, commercial performance, the shear wall option is average, the wall frame option is, we need to consider it as a good because we have some saving if we consider the wall frame option. But considering these two the good items, we concluded to proceed with the shear wall option in this project. So this is the second challenge we faced, and this is the decision that we have taken to move forward. So next, challenges phase 3. I think Professor the Nayanakar and Dr. Musa will interest on this aspect because I have taken some input from the Professor Nayanakara's reports in this the challenges faced and to get the solution in this. So what's the challenges phase? This is challenges phase, design and construction of transfer flow, concrete grade selection and minimizing cement content, thermal monitoring, construction methodology of transfer beams. So this is the transfer beam layout with the bottom load bearing the element, and this is the transfer beams with the bottom load bearing element as well as the top shear walls of the tower. This is the typical one tower. The transfer beams that we have considered this 2300 by 3000, 275 by 2750. Like this way, we had set of transfer beams. So what are the challenges faced and decision taken? Concrete grade selections, concrete grade selection and cement content. This is the challenge actually in this transfer beam. Why we need to actually reduce the cement? I had the discussion with last few days with Dr. Musa. His concern was to reduce the paste actually, because the paste will induce a lot of issues to the cement, the concrete. So a mixed design, the design requirement for the transfer beam is grade 50. Because we have involved with the design and construction consultation of this project, this concrete grade required at which level? So because of we did the analysis of the whole structure, this 50 grade required for the transfer beam, once we construct up to the topmost floor, third first floor, as well as the penthouse and the water tank, and after the construction of all the water tank and machine room and all these things, and after application of the whole the dead load, live load, superimposed dead load, and all these load, after application, only we need this grade 50 concrete for the transfer beam. So therefore, otherwise, if we apply to the whole lateral loads with the lateral combination with the wind load and all these things, we need this grade 50 concrete for the transfer beam. But in order to construct the transfer beam and in order to construct the few stories on top of it, we don't need this grade 50 concrete achievement of this the transfer beam. So we have taken the rational decision here. What was the rational decision? Mixed design 50 MPa at 56 days. So generally, what we are considering is 28 days strength, but we have taken 50 because initially what we need is 35, 40 grade is enough. So with this, we were able to reduce the some amount of cement content of our mixed design. In the INSEE the mixed design in this i2i center, they gave us the standard deviation 3 with a very good quality controlling system, and target mean strength at the 56 days consider is the 55. So we consider two mixed design like this way with the 25% fly ash, 465 cement content and 473 cement content. These are the two mixed design. What are the strength gauge? Mixed design 1, 28 days strength we obtain 55, and 56 days we obtain 61. So you can see around 5 to 6 Newton per millimeter square strength gain is there in this 56 to 28 to 56 days. So we consider this also as one the rational decision to reduce the cement content. So this is the one decision that we have taken, and this is actually extraction from the Professor Nanayakara's recommendation regarding the thermal mock-up, because we performed thermal mock-up for these two the mixed design. We performed two mock-up, one from the computer simulation mock-up, other one is the physical mock-up. So with this mixed design, the differential core to the center to the site's surface temperature difference, generally what we are considering is 20 degrees, could be increased to 25 degrees with this set of mixed design. And core temperature with this mixed design, we could be able to increase it to the 75 degrees. So with that, professor recommended to do the 3 by 2.5 by 2 meter the mock-up. So this is the mock-up, the thermo gauge laying out. This is actually the computer simulation done by the i2i Innovation to Industry Center, this center. So in this, what they have considered is the initial temperature as 20 degrees. So what they found, their observation was the maximum temperature different, the core temperature is 74.7 and the temperature gradient is 24 degrees. So with that information, we perform the physical mock-up also. This is the physical mock-up what we have considered inside. You can see some set of pictures in this physical mock-up. What we observed in this, what we have done is initial pouring temperature we reduced to the 18 degrees, and observed temperature, the core temperature rises 73.8 and the temperature gradient is 23.5. So this is our observation. So therefore, this is the recommendation what we have obtained with the Professor Nanayakara's help. The concrete mix design Portland fly ash cement used in the mock-up acceptable to give the maximum temperature rise below 25 degrees, and the temperature difference below the 25 degrees, and all the parameters are within our limits, and we perform our construction accordingly. This is some pictures of the transfer beams. So you can see this, although we consider 3-meter depth the mock-up, we consider the first part of it, 1-meter depth of it first, because of loading issue at the down level, because we had to do the repropping arrangement at the down because this is at the 5th level of the structure. Then we had to face to the repropping issues. So therefore, first we construct the 1-meter depth, and subsequent part around 2.5 meter next. So here, what are the challenges and what are the lesson learned? Controlling of temperature, construction of large transfer beam at the upper level. So what are the decision taken? Optimum concrete need to be selected for transfer elements such as pile caps and transfer beams. When you are doing the designs, we can every time we need to think about to the optimum the concrete grade, because arbitrarily if we increase the concrete grade, it will not help to the structure, because we are transferring issue to the site actually, because we can do all the alternate designs at office stage, and we can transfer minimum amount of issues to the site based the minimum amount of site to the site the issues to the site, because we can do the alternative designs at the office stage with the reanalyzing and all these things. We know that the grade of concrete will not largely affect to the bending capacity of the structure, because it's marginal effect to the bending capacity of the structure increasing the grade of concrete, but it's actually effect to the punching and the flexural shear. So therefore, increasing is the grade of concrete is required, but it should be with the with the optimum level. So there, if we do like that way, the issues at the sites are very less. Good quality controlling can reduce the standard deviation mix design and can limit the cement content of the concrete mix design, thus minimize the heat effect. I have seen in some grade 30 concrete, the cement content is 400 kilograms or more than 400 kilograms. So why is that? Because of the standard deviation considered in the mix design is very high. So they have considered instead of grade 30 concrete, they are considering target mean strength as more than 40. So in that case, their cement content is very high. So we need to rationally think about all these things when we are designing the mix design also. It's another aspect. For PPC concrete, 56 days will add 5 to 6 Newton per millimeter and can further minimize the cement content and minimize the thermal effect. Two-stage concreting of the transfer beam will help to manageable formwork and false work arrangement, backpropping arrangement. Necessary designs changes to be done at the interface of the two-stage of concrete. We need to address the two-stage concrete. Especially, we need to apply some additional effort in that interface. So, challenges phase 3 and 4. The BIM integration. In this kind of large project, you know, the BIM integration should be done in this kind of project. What are the requirement of BIM integration? To have integrated design approach between all discipline, especially MEP coordination and architectural structural design. What are the advantage of it? Class identification, minimize the rework, enhance visualization and cost and time saving. So I'll just show you VIM platform, what we can use in commercially. Generally, you know that the Autodesk Revit, the mostly use VIM platform, and this is Navisworks. This is free version of the AutoCAD to see the 3D view of the MEP and structure. And Tekla structure is also there. This is specialized to the structural aspect of the thing. So this is our VIM integration and the output that we have taken from the VIM model. So you can see all the ducts, sewers, and all the lines are integrated in with the structure, and we can get all the structure punching as well as the electrical and all other aspect we can consider in this. In this, we can move this space from here to there in the Navisworks file, and we can see all the MEP and all other system, how it works. So we can move this space here and there, and we can get 3D visualization in this structure. So these are few output of PIM integration. So you can see these are the ventilation ducting and electrical and all items included. So some pictures. These are few ongoing captures of the project. This project is almost in the finishing stage now. This is the ongoing few captures. So now challenges phase almost, I think I have completed most of the challenges phase section in this related to this project. And now I would like to go to the novel method of structural monitoring system. What we have done recent past. This is actually a fiber optic monitoring of the structure. In this novel method, we have divided this into two parts. One is the laboratory, laboratory evaluation and laboratory the calibration of the instrument and the fiber optic cable. Second one is actual application of the this method to the actual structure. So what are the fiber optic monitoring of the structure? Monitoring of the structural health by using fiber optic cable inserting inside or outside of the structure as identified as the fiber optic monitoring of structure. This is some kind of inserting nerve system and brain system to the structure. Once we insert this system, this fiber optic cables to the structure, we can monitor all the responses of the structural element in this structure. That behavior, stresses, strain, and all these parameters. What are the institutes involved in this? The University of Moratuwa involved for the sample testing and calibration part. Especially Professor Malik Fransing and Dr. Kasung Karyosam involved for this. And University of Cambridge and University of Oxford and Access Engineering PLC involved for this monitoring program. So this is the monitoring analyzer what we have procured. You can see monitoring the central brain system here, what we can identify like that way. And these are the fiber optic cable. There are two types of fiber optic cable. One is temperature cable, other one is the strain cable. So the temperature cable actually in previously we observed that when we are measuring the temperature of the mock-up, we need to insert the temperature gauges everywhere. But in this cable, we can get results each 200 millimeter interval of once we lay this cable inside the cube, we can get every 200 millimeter interval to the computer, and we can evaluate all these things, the temperature as well as if strain is there, then strain also we can get. So this is the lab sample done to calibrate the fiber optic cable, because we can't directly use this system without having any calibration. So what we did was we used the temperature gauges and fiber optic cable, temperature cable, and calibrate it, and also strain gauges and strain the fiber optic cable and calibrate the machine. So what are these are the samples that we have done at the University of Moratuwa laboratory. You can see the red color is the thermal, the fiber optic cable to measure the temperature. Blue one is the strain measurement fiber optic cable. You can see the samples like this. What are the outcome of the testing? Strain measurement as per the strain gauges and the fiber optic cable readings are exactly tallying, including outside strain gauges reading. This is very important point, because the completed structure we can insert only from the outside. So therefore, outside strain gauges reading and outside fiber optic cable gave the same results. If we have compression element, we need to apply small pre-tension to the fiber optic cable to get the correct answer. This is the second finding. Temperature measurement obtains is exactly tallying with the temperature gauge measurement. So this is the third observation. So real-time monitoring, now we are planning to have monitoring of the pile foundation and the axial shortening and the structural response monitoring of the heavily loaded column. The importance of this is when we are doing the pile foundation, generally we are doing the testing at initial stage. Once we insert this kind of the fiber optic cable, we can monitor, we can get the results once after construction completion of the superstructure also. So we can get what are the deformation, what are the stresses, strain undergoing in this the pile foundation, because previous case we can't get this kind of information. Once we done the superstructure construction, that's done. We don't know what will happen to the pile foundation after that. So we can get more information about after construction of the superstructure. So this is our achievement in this fiber optic monitoring. Dr. Kasum Karyavasam and Professor Malik Ranasinghe has published this one in the Engineer UK, and the Engineer UK selected this as the winner of the 2023 Information and Data Connectivity sector, the winner of the 2023 year. So that's our achievement. So these are the benefits that I have mentioned here. The another benefit is there, we can monitor the geotechnical vulnerable areas and the develop the early warning system as well, because in few months back we had a lot of rain in this country, in the whole area, and we observed a lot of geotechnical failures and the retaining wall failures and the slide failures. So this system we can use as the early warning system for this for these failures. So this is, I would like to conclude my presentation with the following the items. First item, what I have describe is the rock profile observation. Detailed test in subsurface rock profile gave vital information so that alter the design most constructible way considering the environment and environmental time and cost. This is one aspect what we have considered in this Marina Square design. Second, evaluate the structural form of the proposed towers and selected most suitable one considering aesthetic, structural and functional performance and also the cost. Evaluated most suitable concrete mix designs for transfer beams with better thermal performance and two-stage construction of transfer beams to minimize the loading impact below levels and backpropping arrangement. Integration of BIM to clash detection, minimize subsequent modifications and smooth coordination. Finally, novel method of structural monitoring system to enhance knowledge about the behavior of the structure. These are the conclusion of this my presentation today. So I would like to acknowledge my design team. During introduction, they introduced me. I have done a lot of project in this under my name, but without this team, I can't do anything. So therefore, the team is the most important, and I would like to acknowledge my team as well as the Harbour Village Private Limited team that they gave a lot of support to finalize and successfully completion of this thing. KTP consultant for the consultation of the structure, a member of Surabana Jorung group. DG5 and Heterogen for the architectural works and the BIM integration. China Harbour Engineering for the construction part. Professor Nanakar and Professor Malikrana Singh, University of Moratuwa, I would like to acknowledge to them also their support given to this project. And last and not least, INSEE Limited and Innovation to Industry I2i Center gave a big support to giving me the opportunity and giving all the thermal monitoring supports and all these things. And I would like to acknowledge all this. And thank you very much for your patience for this presentation.
After sharing a lot of knowledge, after sharing a fruitful session, after sharing your experience, still we are not allowing you to go down, but we need you to be seated on the stage because next session is the Q&A session. I saw Professor Nanakar also was very eagerly looking at the presentation, one of his students. So in order to run the Q&A session, I would like to invite Engineer Amit Adhikari, Manager Products and Solutions Development. Engineer Amit.
Okay. Okay, Dishan, thank you for inviting me to proceed with Q&A session. So, Engineer Dhammika, I should say that I have seen you have given extra step than what we are using. I mean, challenging standards, but theoretically, practically shown. So we will have a few questions to be clarified from you, our audience. Today we have both physical and online audiences. So first, as a startup, I will go with my question. I want some clarification. So, Engineer Dhammika, I show that in your presentation, firstly, a proposal was given to for your mass power maximum temperature 70 and difference was 20. But in actual conditions, we have to went for the around 74 and 24. Then we got the recommendation 75 and 25 It's okay. I mean, I just want to know, was there any impact or issues you understand you shown in your structure, in your transfer flow?
Actually, in this concrete, we did the transfer beam in the 2-stage, but in the mock-up, what we have done is the 3-meter height and the given the dimension. But in this actual case, this 3-meter it's not the 3-meter. Actually, it's 2.5 or lesser than that. So therefore, we observed that the temperature increase is lesser than the 70. But to answer your question, we have observed around 73, 74 in some other project, and we in order to get the I mean to see the quality of the inside concrete, we drill the and check what has happened into the inside concrete in this thick pile cap, and found that with this kind of mixed design with the fly ash 25%, we observed that nothing has happened. The concrete grade and strength achieved very well. So therefore, with this, the recommendation of the 75 and the 25 can be done with that fly ash, but for the special recommendation of the plywood thicknesses and also the insulation thicknesses, we need to consider as per the special uh, recommendation. But we observed that the concrete strengths achieved.
Okay. So do you have any questions from the physical audiences?
Very good presentation, Ramika. Very nice presentation, and actually you have faced the very good challenges over there. I have two questions. One is in the mock-up. So why did you do it above the ground? Because I saw that you have lifted the mock-up test, no? Mock-up test. You did it above the ground, not on the ground level. Is there any particular reason?
Actually, the professor recommendation was the in that. I think you didn't see that recommendation. In that recommendation, it was there. It should not be done at the bottom on the ground, because our transfer beam at the 5th level and the 6th level. So therefore, in order to simulate that criteria, we have raised it. The professor recommendation was the minimum 600 millimeter above the ground. So that's why we have done that way.
Okay. The second question is in the transfer beam is very important element. So you did it in I think two parts, two stages. Yeah. So if you did the same thing in the say one stage, would the design will be completely different, or was there any?
Actually, in the 2-stage concrete, because why we did that thing is also need to be considered, because if we consider the single-stage concrete, our concrete thickness is more than 3 meter. So therefore, our backpropping arrangement and all the other strengthening part should be done. So therefore, that's why we have considered the 2-stage concrete. Most of this kind of transfer beam at this kind of level, I mean the bow level, generally we practice in the 2-stage concrete. So the design aspect wise, we need to consider a few things additionally when we are doing the 2-stage concrete. First one is the once we complete the first stage, the top surface shrinkage and thermal cracks we need to address. So therefore, we need to apply some set of reinforcement on top of the first stage concrete. And also second one is, of course, we need to green cut all these things for the aggregate interlock, as well as we need to put additional dowels to take the interface shear. We need to do the different calculation for that, and we need to additionally apply this interface shear reinforcement additionally when we are doing the 2-stage concrete.
Okay, Adhikar, if you allow me to ask one more question, because it's so interesting. You did the modeling here and you did the mock-up over there, and the actual concrete also, I'm sure you have measured the temperature. So what was the differences of the maximum temperature and the temperature gradients?
Actually, I would like to comment on the what they have done in the I2i center. In this, they have done uh, in my presentation. I showed that they have done initial temperature as the pouring temperature as the 20 degrees. They have reached around 74.7 or something like that. It came to the marginal. So therefore, professor's recommendation was to reduce the pouring temperature to 18 degrees. So the mock-up, physical mock-up, what we have did was with the 18 degrees, what we have reached the maximum temperature is a 23 point something. So then we have full confidence that with this 3-meter height, the value will not increase the maximum value and also the difference. So again, we have done another thing with the 2-stage concrete. Uh, the maximum height what we have done is 2.5 meter or something like that. Therefore, the temperature rise in the actual case below the 70 degrees.
Thank you very much.
Thank you for your question.
And one thing before proceeding, I mean, when we discuss mass pouring thermal mockup, I cannot, I mean, go without Professor Nanaka. So anything from you? It's better to give your comments, please, for our audience.
Okay. Thank you, Dhamika, for your nice presentation and highlighting the important aspects that you have considered in your design and also the construction stage, the challenges that you have faced and how you overcome those things. Yes. With respect to mass pouring, as you said, I mean, conventional, everybody specify temperature differential of 20 and the maximum temperature rise in the core to 70, irrespective of the grade of concrete that you are using, irrespective of the type of cement that you are using. But those two are related to the type of cement. So, and the grade of concrete. So that is why I have recommended for grade 50 concrete. It is not 20. You can go for a higher temperature differential because that depends on the stress developed and what is the limiting stress with the grade. So why we are limiting the temperature differential? That is to limit the stress developed due to temperature differential at the surface, and sometimes it can be at the core. So higher the grade, you will have a higher tensile strain capacity. That means you can go for a higher temperature differential. So normally this 20 came from grade 25 or 30, right? And also there's something other important factor that we don't have a reliable research, the type of aggregate that we are using. So the alpha value, the coefficient of thermal expansion is another important factor to decide the temperature differential. So we have charnocite and we don't have, very reliable research with respect to charnocite. We are using the granite temperature properties. So assuming that one, we are getting the temperature differential for grade 50 concrete around that 25 degrees, right? So those two factors are the important factors deciding the temperature differential. Then the second one is the core temperature. Now that is something to do with the defect called the ettringite formation. So delayed ettringite formation. Now this was first discovered or came across when you are doing the Southern Highway, pile cap cracking. So after that one, after doing extensive study, we came up with this delayed ettringite formation is the main reason for pile cap cracking. For that one, the main factor is the early age temperature rise. Early age temperature rise. So if the concrete temperature exceeds the limiting value or critical value at early age, there's a possibility of formation of this delayed ettringite, which can be even after 2, 3 years, it can be after 10 years. We don't know when that will happen. The concrete will expand and crack. So to prevent that one, we have to control the temperature rise at early age. So this critical temperature, again, that depends on the type of cement. So there's a one, very comprehensive document published by the atomic energy authority in France, French recommendation. They have given a very comprehensive guideline with respect to this temperature controlling to prevent the delayed ettringite formation. So yes, yes. What do you call it? LCPC, right? So he knows in French that is in short term LCPC, no? Yes, yes. So they are uh, they give a very comprehensive guideline depending on the exposure condition, whether it is completely wet or wetting and drying, and also depending on the type of cement, what should be the limiting temperature. So from that one, I obtained that 75. Otherwise, everybody recommends 70. I mean, even with the fly ash.
Actually, sir, it's 70 is very challenging actually
Yes,
because
yes,
when
yeah.
we observed in every cases it's 72, 73, we need to.
I mean, definitely it will go beyond that one.
Yeah, yeah.
Definitely it will go beyond that one. So, I mean, we must not blindly apply these specifications. We must see the basis for this one. No? So, and we have done research on this one because we studied, I mean, we investigated the first this pipe cap cracking in Southern Highway, and we did some research on this, how to control this one. And with the collaboration of Japanese university. So we found that if you use the fly ash, you can suppress this delayed TTI formation. Very, very effective one, right? So that is why, I mean, when you have the fly ash, we can relax this limit. We can relax limit, and that report supports that one, right? So that is why with confidence that I mean we can go for that, not because of that our research, but even that international, research organizations also support that one. By using fly ash, you can relax that limit, right? So if you're going for OPC, definitely I think you have to limit to 70 degrees, right? Because with OPC alone will not be, so effective in controlling the dilated tringite formation. So I think that is enough, isn't it?
Okay, thank you, sir, for your inputs. So, yes.
My question is actually it's very well answered to controlling the temperature. Have you tried to control the early losses of temperature using some form of insulation methodology on this beam concreting?
Yes, of course. In the sample, the mock-up also, we have done the insulation and the thick plywood, and definitely we need to insulate it so that the temperature difference to maintain 20 or 25 degrees. What is the specification? So definitely we need to insulate the with the thick plywood, and the top surface insulate with the some the material, yeah, styrofoam or some materials, yes.
No, I mean not the mock-up, the actual application.
Yeah, actually, in actual case, the first 1 meter we didn't do, but for the second half, yes, the first 1 meter, the because of the this all the reinforcement requirements not necessary because the thickness is 500 millimeter and the 1 meter maximum. So the second part, we applied all the things and measure all the temperature, and the temperature actually because of the depth is lesser than the so around 2.5 meter, the temperature reach was less than the 70 degrees in that case.
Good evening. Very informative presentation. Thank you very much, engineer. So my question is that you mentioned that you selected the shear wall frame rather than the wall frame. So with that, with this project, it's very challenging to convince the architect. So because the project has to have nice aesthetic features and opening and things. So how you manage that part?
No, actually, this the wall frame structure and the shear wall structure came from two different the architect. So therefore, once we select the shear wall the structure, the we proceed the project with the shear wall structure. The architect who suggests the shear wall structure. So therefore, we didn't face any issue with the that situation. So if suggestion came from the single architect, then that kind of issues would have happened. But we fortunately didn't face that kind of situation.
Yeah. So let me bring some one of main question raised by online participants. There are two questions that I will bring as one. It's about the monitoring strategy by using fiber optics. What are the outcomes readings we are taking for making decisions for proceeding with repairs, and can structure cracks also be detected by it? Second one is, yeah, sir, can you explain more on using fiber optics for analyzing existing structures, as it's new for all of us?
Yeah, the first question, the reading that we can taken is the temperature reading we can get, and also the strain measurement we can get. So based on the strain, all the stresses and the other, if you need to back calculate the forces and all these things, we can back calculate it. So that is the answer for the first question. The second one, yes, existing structure we can measure, as in my presentation also in the sample the mock-up, we have done that the calibration also with the outside strain fiber optic cable as well as the outside strain gauges, and inside fiber optic cable as well as the inside strain gauges, and found that all the results from inside and outside the strain gauges as well as the strain cables are tallying. So therefore, the existing structure we can monitor with the fiber optic cable. And other one is whether we can see the crack. Is that? Yes. If existing cracks are there, then in the fiber optic cable there should be some measurable strain. If the existing cracks are there, then once we paste or once we glue to the fiber optic cable to the structure, if further increment is not happen in the crack, we can't measure, because the further the strain should measurable. Strain should be measurable. Then if strain is not there, then we can't measure. For the existing structure is the live crack, then we can measure once we apply it. But if it is steady, we can't. Yes.
Okay, nice. Then, yeah, I will move to another question. That's very valuable also. Sir, can you please explain more on changes phases, and how did you manage with consultants to go for 56 days strength? As most people here would have experienced 20 days strength as target. Is so
Actually,
from
that is because we have done the design and we have done the consultation. We can get this kind of decision, as I explained. because the grade 50 requirement is coming at the all these the combination with the live load, dead load, superimposed dead load, and all these consideration. So therefore, if we reanalyze the structure with the transfer beam and the with the upper few floors, five, 6 floors, uh, the strength requirement would be 35, 40. So therefore, we can get that kind of decision, rational decision. If it is support to the minimize the paste as we discuss, it is if it is support to the structural quality, final quality, then it should not fear to get that kind of decision because although the 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 specification could be like that way, but we can get rational decision like that way by considering all aspect because it's the quality of the structure will increase because we could be able to do the grade 50 concrete with the 500 to 550 cement content using the cement content, but what is the final outcome? Then it will the form the DEF and all the issues will come finally. So therefore, it's now today's. I think it's better to think about that way and get that kind of decision when we are uh, doing the consulting as well.
Okay, nice answer. So, do you have any questions to raise? Yes.
I mean, I have several questions, but one important for tall building. Uh, you you were talking about the lateral forces, right? People can feel seasick when they are on the top, right? Uh, Therefore, very often we design column with high strength, not only to gain space because you have less volume, therefore you can rent more, you can sell more service, but you make the structure more rigid because your E modulus increase. You can go from 25 up to 40. You can reach even the E modulus of aluminium. Therefore, when you see today tall building, we always go for 60, 70, 80 megapascal to take fully advantage of these two properties. Now, in your case, when you have decided for the cost benefit, right? Have you taken this into consideration?
Uh, it's a good question. So I will answer this question like that way, this way, because uh, if we arrange our structural element such a way that it's effective to the lateral forces, so we can reduce our structural element so that we can get the internal spaces. But if we reduce the structural element sizes and increase the E values, like you say, with the increasing of the grade of concrete or whatever the things, I don't think it's the good approach because it will come to the some issues at the site. But uh, the in my case, because we the architectural designs support to us to the go for around grade 40 and 50 in that range to uh, our structural element are large such a way that and also the arrangement also effective to get the lateral forces. So therefore we haven't faced that kind of issues with this in this our particular case.
Okay, thank you.
Dhamik, I have several questions, but I will start with the durability aspect of the structure. I think the Marine Square, I think, exposed to severe environmental conditions, right? Um, Sea spray exposure. So, when it comes to the design and construction, how did you address that one?
Yeah, actually, we when we are considering the grade of concrete and the when we are selecting the cover of the concrete, we have considered Eurocode actually for this situation. So therefore, this specific condition we consider nearby the sea spray and all these condition. I can't remember what is the XC or what are the what
Yeah,
is
no,
the,
no. I
yeah,
mean, you follow the
yeah,
Eurocode
follow
recommendation.
these things, and
Mhm.
all the grade of concrete and the cover to the reinforcement we have selected accordingly. And also we included the tolerances due to construction deviation as well, and we follow that as the criteria and selected all the parameters for the skin walls, mainly skin wall, because that is the vulnerable the element of the structure.
So, I mean, so that means you follow the Eurocode in design aspects as well.
Yes.
So, I mean, in the Eurocode, when it comes to the structure analysis, I mean, they recommend the reduction in stiffness. So, have you used that one, or I mean, the reduction stiffness?
Yes, we have considered.
Yeah.
Yes.
So, when it comes to the Easy 8, I think they are recommending 0.5 reduction of the stiffness. So for the all the elements, but when it comes to STM, it is different. No, for flexural members and compression members, different factors are there for the stiffness reductions. So which one that you have used?
Yeah, actually for the slab designs, we have actually make the zero for the slab design in order to do the beam design. So we all the loads taken to the beams. So beam designs we performed with the slab stiffness as zero. As you said, the for the vertical element, yes, we have considered 0.5
As recommended
as
in
yes
the-
recommendation.
So sorry, I'm asking a series of questions. Now with respect to durability, now when it comes to MEP, right? So if there are outdoor AC units, I mean very critical, isn't it? The corrosion. So how do you all take decisions in selecting? I don't want the name and other things, but what are the factors
Yeah,
that you are
actually uh, for the handrail and all this, we have done the marine grade paint actually. For this uh, this part for the special your question, actually I don't have the answer for this moment because I don't know what kind of things they have already
they have
selected.
considered?
Yes,
Yeah. So, but I mean, the that is also very important part in these high-rise buildings and the maintenance and when it comes to maintenance, that is very important. Right. Okay. Thank you. Thank you.
thank you very much.
So, do we have? Yeah.
Thank you for your presentation. And regarding MEP services, when you are providing MEP services, we have to provide spaces as well as openings. And if you provide below the ceiling, then you have to go the difference between floors, you have to increase. So how did you address in providing MEP services in this bill?
Actually, in the corridor area, we have separate ceiling and the washroom area. For all other areas, the concrete there are no any ceiling. So for the uh, services mainly passes through the corridors. So because in this there are two types of buildings in this particular project. In one floor, the first two towers, four units per floor, one floor, but other one it is around eight numbers units. Uh, so all the services passes through the uh, the corridors and using the bulkhead, uh, we take in those services inside to the building. So therefore, ceilings requirements are only in the corridors as well as the washroom areas only.
What about in the transfer flow? How you take it out?
Transfer beams, actually, we have arranged all these things such a way that transfer beams not be punched, but some small 2-3 cases came actually their requirement. So for that, what we did was we kept uh, the the uh, the ducts like iron duct throughout the beam to get those lines to down.
Okay, thank you.
Okay, then I hope that we can conclude the Q&A session with that because we answered all filtered questions. So thank you, Engineer Ambika, for
Thank you.
Dishan. Over to you. Okay, one last question, Dishan.
Thank you, sir, for your presentation. This regarding that heat of hydration. Actually, now I have understand that we try to minimize the placing temperature for mostly for the mass concrete because as for our understanding, the delayed petroglyph formation will happen mostly in mass concrete. But in general practice, in the industry, we have seen that even for thin slabs, there is a limit for placing temperature. So is there a real reason behind that, or is it just mispractice? I just want to clarify.
I think it's better from can
Yeah,
answer the
that's
question.
I also thought that. No, sir. The question was there's some limitation for placing temperature for mass pouring concrete. For the general concrete also, there was a limitation for the mass pouring concrete. For general concrete.
Very good question, right? Actually, now when it comes to the fresh concrete, fresh concrete temperature specification, right? I mean, you can find so many limitations, right? Different countries gives different values for the normal fresh concrete temperature limit, right? But there should be a basis for that one. No, it should be related to our environmental conditions, right? When the environment temperature is above 30, what's the point of reducing fresh concrete temperature below 30? Within no time, it will come to the environment temperature. There's no effect of that one. I mean, you are spending more money in vain, right? So there won't be any benefit. But we have to handle this problem in two ways. One is for mass pouring, other are for normal concrete, right? Mass pouring, yes, we have to control it. But I mean, he has explained to limit the maximum temperature rise and to limit the temperature differential. For that one, we have to control the fresh concrete temperature. But for the normal concreting means not mass concrete, not for thick elements like slabs or columns. It depends on the environment temperature that we are dealing with, right? Now we did a research on this one because this is an important factor that we have to address because this is a one that industry should know, right? Uh, so we found that if you reduce the temperature too much, that will negatively affect the concrete. Both ways. Not too much, not too much. The best performance is close to the ambient temperature. Your fresh concrete should be close to the ambient temperature. Then you get the best performance. Okay.
Thank you, sir. This over to you.
Thank you, Engineer Amit Adhikari, Manager, Products and Solution Development, INSEE I2i Collaboration Space, INSEE Innovation to Industry Collaboration Space. Ladies and gentlemen, I would say when you listen or when you hear the Q&A session and also the fruitful session conducted by Engineer Dhammika Gamage, this is the key objective. This is the key goal that we wanted as INSEE to create the platform to share the knowledge, share your experience, share your exposure. So then only, as I started this session, knowledge is power. Sir Francis Bacon. When we share the knowledge, ladies and gentlemen, you and me, we all know that uh, the situation in this country is in a not in the most positive way. But with knowledge, with sharing experience, with sharing exposure, I'm sure we all can elevate this country, this industry, this economy to another level. This is the platform, this is the goal, this is the objective we want to create platform to share this know-how. Ladies and gentlemen, you can see, I think, well-known management guru Peter Drucker has said, which is getting measured will get managed and improved. So we need your feedback to improve the quality of this session, support services, and the organizing and all that. So please, you can scan and give your feedback. You can scan this QR code and give your feedback. In order to give the token of appreciation to engineer Dhammika Silva, may I invite Dr. Musa Balbaki, Director Products and Solutions Portfolio, INSEE Cement, and also Engineer Nandana Amunuthuduwa, Director Industrial Sales, Building Materials, and INSEE Concrete. Two directors of INSEE Cement. Sirs, may I invite you to give away the token of appreciation to Engineer Dhammika Silva. Engineer Dhammika, thank you very much for your time and effort. And I'm sure these preparing these slides are also not easy. Huh? So thank you very much for your contribution and sharing your knowledge and experience with us, with your fraternity members. Thank you, Dr. Musa Balbaki. And thank you, Engineer Nandan Amunuthuduwa. And also thank you again, Engineer Dhammika Silva, your presentation and for your participation here. Before we close the session and invite you for the fellowship dinner to the cafeteria, I would like to invite Dr. Musa Balbaki, Director Products and Solutions Portfolio, INSEE Cement, to give away the vote of thanks. Dr. Musa is leading the INSEE i2i innovation to industry. He mean it because he needs to empower the Sri Lankan engineering fraternity while inculcating the innovation culture. Dr. Musa Balbaki, over to you.
Thank you, Dishan. I mean, first, I feel good when I see all these faces. And even though I feel great when I have heard the excellent presentation. Thank you so much, Engineer Dhammika. Therefore, let me start first to thank you all. Of course, what Nandana said, what Dishan said, that of course we cannot really hire all these smart people in this room, but we can engage, we can collaborate with you. And that's why we have this somehow collaboration space. Second, I would like also to somehow, I see the attendance here, we have more than 300 people physically online, even though from the region, from Bangladesh, from Thailand, from Vietnam, from Cambodia. Therefore, I would like to thank all of you for really coming and somehow expressing your interest for this knowledge sharing session. Having said that, I would like to come to Engineer Dhammika, really on behalf of INSEE, on behalf of all the crowd here. I would like to express our sincere appreciation for what you have heard today. This is a really remarkable contribution. It is really important that we keep this kind of like great experience. We went through this great project. When I look you are very young. You know what I mean? I'm really impressed because when I had heard about the CV, I said it's a guy who is about 60 years, but no, he's very young. Therefore, it's very interesting. And thank you so much again for all what you have shared with us. Also, I would like to say that really a big thank you for my team at i2i. You have seen them running all around the room, organizing the presentation, all this stuff. I would like to give some name here. Adhikari, I would like to talk about Mahesh, about Budika, about Asanka, about Indika. All of you, thank you so much. Thank you, our colleague from INSEE Cement, INSEE Concrete, INSEE Mortar, all of you. For being present, for being really always generous. Again, I have to say that to our, I would say our visitor. And I will give the podium to Vikan. Thank you.
Thank you very much, Dr. Musa Balbaki, Director Products and Solutions Portfolio INSEE Cement, not only for your nice thoughts, but also for leading the innovation and innovation to industry collaboration space. And I think you deserve a special thank from Engineer Dhammika, saying not that he's young, but very young. Huh? So, ladies and gentlemen, let me invite all of you to join us at the fellowship dinner. And this is the end of 23rd webinar knowledge sharing session, which is 38. Ladies and gentlemen, it is not an easy task to carry out or organize 38 numbers of knowledge sharing sessions. With this 38th one, we have shared a lot of knowledge, create, uplift, and elevate our industry. That's our key objective. That is our goal. With this thought, let us conclude the 38th knowledge sharing session. INSEE I2I, innovation to industry. Good night, ladies and gentlemen.